Hey guys, welcome back. So we are going to start on our statistical concepts chapter. And what I'm going to do is before we even get started, I'm actually going to skip out of this PowerPoint behind me, and I'll show you where we're going over the course of the next 3 weeks. So you can kind of get an understanding of what this whole kind of mini lecture series is all about. Because once we get started, we're going to kind of stop in the middle and then kind of continue on next week, because I'm going to take this a little bit slow. But I want to give you a full picture so that when we do this like hard stop in the middle, you're not like, what the heck? What are we doing this for? In class, what's going to happen is we're going to focus on this stuff in the lecture, like the stats stuff in the lecture. And then in class, we're going to do some other things. So it's going to feel a little bit disjointed, but the purpose is that by the end of these 3 weeks, we'll add in the statistics part. The class projects will be relevant to the final paper, and then we'll be bringing all these puzzle pieces together. So if you remember at the very beginning, I can't remember if I gave you this analogy or not, but what the intention of all this is that we're going to lay out our puzzle pieces on the table. We're going to flip them all over so we can at least see the colors, but they're not all really going to make sense. It's not going to make one full complete picture until we get to the end of the semester, or at least further along, probably closer to the midpoint, when these puzzle pieces start to come together and you're going to see the full picture. So during this little mini series, we're going to, I don't know if you guys are puzzlers or not, but during this little mini series, what we're going to do is find sort of light colors, fit them together so we can at least see part of the big full picture. Okay, so I know it's kind of a lot and there's a lot of moving parts here, but this will come together and make more sense as we go. Okay, so let me show you what we got here in the behind me. I have to take the captions off, but hopefully YouTube will be able to turn them on so you guys can still access captions if you need to, but I'll come back to these in a little bit here. So we're going to go from statistical concepts. Oops, sorry, wrong button. And we are going to talk basically about frequency distributions, measures of central tendency, and then what we're ultimately going to try and work our way up to is something that's not on this slide. It is, so you can get to the other one. Which one is it? This one. And what we want to get to is percentiles. And the reason for that is because percentiles is the thing. Percentiles, t-scores, standard scores, and a few other standard scores. That'll make sense what that means. But that's the stuff that you're going to look for on your assessment output reports, and ultimately what's going to help you make clinical decisions. For you school counselors, you're going to be able to look at those things, and that's the stuff that goes home to parents. And you're going to be able to explain that to parents and to your students and to your colleagues and all that stuff. What we want to be able to do is talk about those things so that we can say, here's what it really means to you practically in your life and what we can take away from this. Okay. And then the final week, I don't need to spend a lot of time on this, but we're going to be talking about reliability and validity. And we're going to go over things like measurement error. I don't know where it is. There it is. We're going to talk about measurement error. We're going to talk about how much confidence can we have in these scores and what do they actually mean in terms of how much certainty can we pull out of this, and talk about things like correlations and stuff like that. So if you have a science background, some of this stuff will seem kind of elementary. If you don't, I'm going to meet you where you're at and talk about hopefully make some sense of this in a way that's digestible, because there's a lot of stuff that goes into this, and it almost requires a scientific background and prior stats courses and all this kind of stuff. If you guys have taken these courses before, and especially if you've taken them and hated them and been quote unquote traumatized by them, like you still have this kind of underlying fear about all the terms because you kind of recognize them, but you don't really know what they mean. That's okay. We're gonna manage this process. It might be uncomfortable because you might still have that underlying assumption that like this stuff is hard and it's confusing and all that kind of stuff. Do your best to kind of capture it, understand that it's not the most fun part or it's confusing and scary to you, but we will get through this and it will hopefully make some sense in the end. I will share with you guys, I'm going to pull back the other one up here. I don't think that was English. Pull back the other one and pull it up. Something like that. I will share with you guys that when I was in school, I took a stats class and we went through all the math, and we had to use SPSS, which is the Windows software that does a lot of these calculations. we walked through a statistical process in terms of research. And I came out saying, okay, I get the computer a little bit. I can probably do the math, but I don't know what it means. I don't know how to use it. That's why I'm focusing on how we actually use this as practitioners and not so much on what the math is, because while that's important and it has a place, you can learn that in doc school. For me, it wasn't until doc school that I really started to put the pieces together for here's the raw data that we get from this chaotic experience of the world, and then here's how we use math to turn it into something that's clinically applicable, and then something that made sense to me and how I do my work ultimately in the end. We don't have time to go through that whole process, but for me, it wasn't until doc school when those light bulbs started to go off and for me to say, oh, okay, now that I learned that in my master's program, now I see how it applies to my real life. So I'm going to skip forward past that, assume that you have some of that statistical background. And even if you don't, I'm going to skip towards the clinical application. And that's why I want to spend time on the next 3 weeks here. Okay. So again, just to reiterate, today what we're going to focus on is starting at the foundation, understanding this whole progression from our own experience of the world and how people understand their symptomology and that kind of stuff, up to what we won't fully get to is this understanding of percentiles and normative scores and that kind of stuff. So I'm going to be kind of bouncing back and forth between that as we go here. So this is a challenging thing for me to present, and it's a challenging thing for you to understand. So we'll all do our best to get what we can out of it, and then you guys can ask questions if things aren't making sense. So let's go. We'll see if we can do this. So let's start here. When we use the term statistics, I think all of us probably have a general sense that what we mean is some sort of data or information. But a statistic is here's a definition for it. It's just a numerical representation of information. And I'm going to extend that even a little bit further to say information is just part of our experience of the world. When we take in our experience of the world, we categorize it. Remember in weeks past when we've talked about a child will understand what a ball is, and they understand, like, they start to grow this understanding that a ball is this round thing, and they might experience their first ball as red. But then as they get a little older, they realize that blue balls and red balls are kind of part of the same category, and small balls and big balls are part of the same ball category, and squishy balls and firm balls, and even footballs that don't look like balls, but they actually are a ball. You know what I mean? So like, we build these more and more complex categories of things out in the world. And that relates to how we understand people too, and even our own experience of our own symptoms and that kind of thing. So people, we categorize them, these are Americans, those are Germans, these are people with white skin, these are people with brown skin, like that kind of stuff. That can become problematic when we're stereotyping people that don't fit those categories, but we have to have them in order to understand and shape the world that we live in. However, when things don't fit categories, or they get really complicated and our brain can't handle and fit things into the right schema or the right categories, it just feels chaotic. And when we understand things like, let's take an example, I'm going to use this one over and over again today. We understand things like depression, we have to create a list of symptoms that fit this category, and we're producing it as we go along. There's all kinds of different examples of what it looks like in people of different ages and generations, and between men and women and that kind of stuff. And so we look at it and we're confused by what depression really is. And so we have to shape it and turn it into something. And that's what the math can help us do. It can help us make sense of things that are chaotic, because ultimately, look at the first sub bullet point here, data is just meaningless if it's not formed into something that's understandable. So the whole process of the math that I'm going to walk you through how to do that, and we're going to spend some time in class doing that. The whole process of it is just to make sense out of it. And the reason that I'm going to show you it but not make you do it is because it's complicated and you can learn it later, but it doesn't really start to make sense. It'll start to take shape a little bit into something useful, but it's not really useful for clinical application until we have something like a standard score or a percentile. Okay, so the process of it adding a little bit more meaning and turning into something more useful is, I think, going to be helpful in our clinical application. Here's another analogy that I'll uh, I'll use throughout this, and I'll be skipping back and forth between different analogies. Hopefully, I don't get too confusing here. But if anybody's ever made something like bread or baked a cake or made macaroni and cheese, it doesn't really matter what the thing is, but you have to start with raw ingredients. And my son, whenever we pull out, I usually make pizza dough at home. It's one of the things that we do in our family. We make pizza dough. So you take out the water and you put the yeast in the water and you do that whole thing. And then you take out flour. And since he was a little kid, he just grabs like fistfuls of flour and goes, oh, it's so gross. But he loves it for whatever reason. He loves flour in his mouth, and it just makes me like I can feel shivers going up my back whenever that happens because he's got this like big face, and you can just see all the pasty crap in his mouth, the little saliva and whatever. But he loves it, right? Most of us would not put flour in our mouth because we don't see the raw ingredient as that tasty or nutritious or valuable or anything. But when you take water, regular old water, and you take yeast, which we would not eat by itself, and flour, which we'd not eat by itself, you put them together and you manipulate them and change them. Once you do that, then you have dough. And its dough is useful, but you're still not really going to eat it because it doesn't have value to us as people. Like dough is just dough, but it still has to be transformed. Once you put the dough in the oven, then it turns into bread. And bread is the thing that we say, oh, I can use that. I can eat that. And I can do all kinds of different things with it to make toast or pizza or whatever it is. And that's what we're going to do in this process too. We're going to take some raw ingredients like a data set and a process, which is a mathematical calculation, and we're going to use them together to make dough. But it's still not going to be fully useful to us until we get to the end stage, which is the bread, right? So as we go through this, that's what we're going to be doing. We're going to be adding a few ingredients and adding a process, more calculations. One, mixing is a process. Two, letting the yeast bloom is a process. Putting it in the oven is a process. We're going to be doing different processes or calculations, adding ingredients, and then we're going to ultimately come out with something that's useful. That's the goal here. Okay. Now I'm going to step back from that analogy, and we're going to talk about a few other things here just to kind of help ourselves wrap our minds around what we're going to be ultimately getting to in the end. So it's a slow rise here, a slow start, but we'll get there. Descriptive statistics and inferential statistics are two terms that you already know and you understand, but you may not know what those terms mean, but you get the concept of them. And before I even explain that, I'm going to say one other thing here. I know this is a lot. I'm adding a lot of layers here. But when we talk about the scientific language of assessment, and I say things like, there's a lot of terminology here. I've mentioned that in past weeks, in past lectures. There's a lot of terminology that might sound unfamiliar, but really we're going to simplify it and make it easier so that you can translate this professional counseling language into something that clients actually understand. Because they're not counselors. They don't understand all of our acronyms. CBT, DBT, EMDR, NCE, but like all these different acronyms that we use, they don't get it, right? So we have to be able to translate this into something they understand. So when we talk about descriptive versus inferential, that's statistic math people. That's like the statisticians. This is part of their language that I'm going to help translate for you. I don't think we need to spend our time learning that language. When I said that when I was in my master's program and I was doing all the math and playing with SPSS and doing that kind of stuff, I didn't really need to turn into a statistician at that point. I needed to be a clinician, which is why we're doing that. I'm doing that for you. So when I go into these terms and talk about these things, I'm going to do some translating for you, but I'm also going to say, don't worry about the terminology. You don't need to be a statistician, but I think you already know the concept. We just don't need that special language. Okay. So with that said, descriptive statistics versus inferential statistics. When we get to the part of probably next week when we're talking about, see, how do I explain this? When we get to that part next week, I'm going to tell you, we're going to kind of skip over the inferential statistics. It doesn't really become as relevant to us. It's helpful to consume different articles and scientific outcomes, if you're reading about like the efficacy of a certain new treatment or something, it's helpful to understand about inferential statistics, but we don't need to know it in depth. Okay, so now that I've said all that crap, here's the difference. Descriptive statistics are basically just counting up the total numbers of something. If you've ever seen a bar graph or a pie graph, it's just saying, here's how many people have depression or anxiety, or here's how many people vote Republican or progressive, or here's how many people like, I don't know, here's how many people watch the Super Bowl versus those who don't, that kind of stuff. The Super Bowl was yesterday or 2 days ago, by the way, the time of recording this. So that's why it was on my mind. Anyway, inferential statistics. What this is valuable for is taking a small sample of people and inferring something or making an assumption or guess about a larger population. Okay, so like when you watch a commercial and it says 9 out of 10 doctors prefer this toothpaste, or 9 out of 10 dentists prefer this toothpaste, they didn't actually go ask every single dentist in the entirety of the world, do you like this toothpaste or not? What they try to do is they say, well, let me ask some. And if I can ask those some and I get a number that I'm confident about, then I'm going to infer that based on that small sample, I can guess that all dentists, 9 out of 10 of all dentists, infer this. Okay. So that's helpful when we say, we're going to make an assumption about all people with depression or all people with anxiety. They act like this or they have these symptoms. We need to have a process that we can gain confidence in making that bigger inference or that bigger guess about the larger population. Okay. There's more packed into that, but I'm going to save it for now. We're going to spend most of our time just understanding the descriptive statistics, but the inferential stuff will become important in terms of what we understand later on. So we'll come back to that later. So just so you know, you already kind of get that probably, but that's what that means. Scales of measurement. This part here is in every single introductory chapter that I've ever done in my entire life. However, I don't think it's all that relevant to go through these and for you to memorize these. So for this part, if you're reading along in the book or you're watching this lecture, what you need to know about this, I'll explain what they are so you kind of know, but you don't need to remember this. You probably won't be asked this. You might get it like on a test or something, but you can Google this. You can have this, keep your PowerPoints, this one, whatever. It's just not something that's relevant to you. But when you see things like you get a survey, like a customer satisfaction survey, or you're taking an assessment, you'll see questions like, how likely or unlikely? Is it somewhat likely, very likely, or somewhat unlikely, or very unlikely? You see those kind of Likert scale kind of things. Whenever we're talking about nominal data, we're talking about words that represent a certain, likelihood or something like that. That's different than numbers. And so there has to be a way for statisticians to turn those words into a value to do the math. Okay, so we don't need to know about what that means right now. It just means there's a different statistical way of handling that information. All of these 4 things, nominal, ordinal, intervals, and ratios, are all just different forms of different kinds of numbers. And so they have to be handled different mathematically. We don't have to care about that so much. I'll come back and reference this in a little bit, probably tomorrow, I think. And we'll reference it and I'll say, if you ever hear of like a certain kind of statistical calculation method, like a Spearman's or a Cronbach's or something like that. Some of those, those terms are not exactly, statisticians are going to cringe when they hear me say some of these terms, but there's different names of different statistical tools that we have that refer to handling information differently. Again, you don't need to know that, but just know when you see that, this is information you can say, oh, I think it's relevant to the statisticians, but not to the clinicians. Okay, so that's what that is. Now we're going to describe some of these scores, and we're going to start that process of understanding the ingredients that go into our bread, okay? I'm going to take each one of these in different slides, but we're going to talk about frequency distributions, we're going to talk about measurements of central tendency, variability, and then relationships. Relationships we'll actually talk about next week, things like correlation, regression, factor analysis, etc. I'll probably describe them a little bit today, and we'll really kind of dig into them a little bit more later because those are relevant to what kind of assessments we can look at and what we do with the data. But all of these, the frequency distribution, central tendency, and variability, that's part of the process. If we're looking at this as a bread making process, I'll show you the ingredients, which is the data, and then each one of these three things, distribution, central tendency, and variability, this is the process of turning it from one thing to the next, from flour or from flour to dough to bread. Okay, so we're going to be building until we get to something meaningful and valuable, which won't be until closer to standard deviation and what's actually comes after that process, which is the percentiles and standard scores. Okay, so we'll get there by the end of this. We'll be there in 40 minutes. I'll just say that so we can be ready for it. So let's start building. When we talk about frequency distributions, we've all seen a bar graph. We've seen line graphs. What we're saying is how we need a way to categorize the information, and we need to be able to see all scores at once. Okay. So remember a few minutes ago when I talked about inferential statistics, having an understanding of a big amount of data and kind of just like turning it into something useful and valuable. That's all we're doing here. We're taking a bunch of data and saying, how often do I see, how often do men have depression? Well, we can look at a bar graph like this. And if we take the blue, kind of the taller line, this blue taller line in the middle, if you're colorblind, you can't see this, but this tall one right in the middle here, let's say that's one category, men. And this other one next to it here in purple, that's women. We can take different kinds of information and compare them to each other, and just in terms of quantity. These are just descriptive statistics. That's all descriptive statistics are, is just describing something, men and women, or depression and anxiety, or children from Georgia and adults from Seattle or Washington or whatever. You know what I mean? It's just describing something in the world. A line graph is just another way of doing the exact same thing. But when we see data in different kinds of graphs, they look different and they tell us something. We understand them differently. So we use different kinds of graphs and different kinds of representations of the data just so that we can understand it better. The whole purpose is so we can consume it in a more palpable way, something like that. You'll hear the words histogram, frequency, polygon. Those are just different terms for the same thing. A histogram is a bar graph. A polygon is a line graph. Why do we have these? Those are for the statisticians, not for us clinicians. So that's just a translational thing. So don't worry about memorizing those words. We don't care. That's just not something we care about today. So, I didn't mention general patterns of generally high or generally low, but that's the same thing as saying like, the blue line versus the pink line, whatever. Just we're seeing patterns here, themes. Clusters or concentrations of scores. Cluster and concentration, those are different ways of seeing information so that it's palpable. That's all we're talking about here. I think that's one of the hard things about reading the chapters is it's written for statisticians. And I think it's part of the reason we're scared of this stuff, and part of the reason we find it hard to figure out how to use it is because it's written in a different language, quote unquote. And so that's why I'm really trying to translate this for what's useful. Measures of central tendency. You guys all learned about this stuff probably in like high school, like a long time ago. We all know what mean is. Most of us remember, well, we know how to calculate averages. We know what they are. We don't always know what to do with them, but we kind of understand it as a package of information, right? If I say I have a bar graph with men and women, and I want to find the average between those two to say what kind of is the average of all people's experience, I'm going to find somewhere in the middle and say the average of that. In other words, I'm going to take my flour, take my yeast, I'm going to average it and make something else like dough that makes it more useful, right? Okay, so finding an average is just another layer of a process to make something useful out of numbers, okay? We don't really typically use medians or modes all that often in clinical assessment. You will in research, and I'll tell you a little bit about what they mean, but one other distinction that we need to understand is when you guys take the research class, you're really thinking about a different kind of statistics that are more relevant to that stuff than it is to our clinical assessment world. So one of the things I'm going to try and distinguish as we go through this is what parts are relevant to your clinical work and what parts are relevant to you as a practitioner who consumes research information, okay? Because some of the math and some of the stats are relevant to how we understand things like correlations, but correlations don't really show up on assessment all that much in terms of like understanding standard scores and the outputs of our clinical assessments. They're not often used in terms of correlation. So there is quite a bit of crossover. If this is like a Venn diagram, there's a center area where we're seeing the use of things like correlations and medians and modes, but it's just not that much. So sometimes I'm going to say this is relevant to you as a clinician who's giving assessments, and this is relevant to you as a clinician who's consuming research about clients and diagnoses, things like that. Okay. So the mean is part of our bread making process to understand percentiles and standard scores and things like that. We'll get to that. The median and the mode, those are more relevant to the research. The median, I'll spend just a second talking about these. Median is the middlemost score and mode is the most frequent score. More importantly, the difference between mean and median can sometimes become important in certain contexts. Here's a kind of a classic example. If I took everybody in southern Wisconsin, Milwaukee, Madison, Janesville, all these kind of these cities, and I want to understand what's the average income of all these people. Well, there's probably, let's say it's just 50,000. We'll use just kind of a round number. Let's say the average income of people in all these communities is 50,000. And then for some odd reason, we get a whole bunch of people like LeBron James and Taylor Swift. They say, I'm going to move to Delavan. I really want to live in Delavan. It seems like the best place on earth. And all the people in Delavan are like, well, the average income of 50,000 doesn't really make sense for us because we don't live in Milwaukee and Madison. Those communities are expensive to live in. So it doesn't really represent us well, but it's a little bit closer. But now that LeBron James and Taylor Swift move into Delavan, now the average income jumps from 50,000 when it should have been 30,000 to begin with to like 150,000, right? So it skews the data when we have big numbers of people that are coming from these different places. And the reason we use median scores and sometimes even mode scores is because we want to cut off those outliers. We want to say what actually represents the real experience of the world. Most people in Delavan aren't even making 50,000. We might say that's close to the average of people in southern Wisconsin, but for those folks in Delavan, it might be only 40 or might be 35 or whatever. So if we take off the really high scores and we take off the really low scores, we get closer to understanding what the experience of most people or the most frequent score or the middlemost score. So there's different reasons for wanting to use these different things to understand the data a little differently. But in our process of understanding, taking raw data to something useful from flour to bread, the mean is really the thing that matters the most. And we will talk about mean as soon as we get to our frequency distribution here in just a few minutes, and we'll talk about that in class. That'll be useful to us, but the rest of these really won't. They are valuable, but not so much for our conversation here. So you'll also see things in the book about skewness and kurtosis and that kind of stuff. That's relevant if you're doing the math. So if you're reading that part and you're like, do I need to know this? The answer is no. I don't think there's ever a time I've been asked about that stuff on any kind of test. I've never used it in the process of clinical judgment. I've used it when I was doing the math, but not when I was doing clinical work. So for that part, I would just skip over that part and come back to it later. If you're planning on going to doc school or doing some research or something like that, you can come back to it. But for now, don't worry about it too much. If you want to know the math, it's really important. All it is that when in a few minutes, when I show you a normal curve, we've all seen the bell curve or the normal curve. If that's what sort of the norm is, but you then take a specific subset or a sample of data from another place, it's not going to fit the norm exactly. For example, if I say the normal income is 50,000, but I map out all the people in Delavan who really only make about 35, there's going to be more people on that lower end of the income scale. And so there's going to be a little bit of a lean to our graph. That's all it is. It's the graph, it's the numbers, it's looking at specific subsets of information and how they differ from what is considered normal. But again, we don't need to worry about that for our purposes here. The one last thing is when we get to the symbols, we're going to be seeing in the book, as you're reading through and you're seeing all these calculations. I always love that the one that looks like a big backwards E or forwards E. When I was younger, I was like, I don't know what that thing means. I don't understand the mathematical symbols. And then there's like these fancy, when we get to like Cronbach's alpha later, there's these like italicized lowercase things. Again, that's for the statisticians. Some of that we'll want to know, but I'll explain that here in a little bit as these things come up. There's really only a couple that are probably relevant to us. Most of them are relevant in consuming research. So the Cronbach's alpha, how do we recognize what a correlation looks like and how people talk about it or symbolize it in the research? That'll be helpful for us, but not quite so much in terms of what we need to know to be clinicians. And that big backwards E thing, it just means addition. It's just how you sum up things together. So again, we don't have to be able to do that. I just don't want it to look completely foreign to us and for us to be too confused. So I'll explain that when we get to that part in the book. Okay, so now let's talk about variability. We've taken our flour, turned it into dough, and now we're going to put it in the oven. What that means is we take our raw data, we've categorized it, made some descriptive statistics out of it. We've seen some graphs about frequencies and some line graphs, that kind of stuff. And then we've already manipulated it a little bit to do some averaging or to get measures of central tendency. When you look at the calculations in the book and the way we'll go through the math so you can see this stuff, but we'll do it together. I'm not going to make you calculate this stuff. But when you do it and you think about this bread making analogy, you'll see how one thing builds on another. Okay, so we'll do that together. If you take the average, you can add another mathematical calculation to find the variance. So the average gives you a little bit more than just the descriptive frequency, something like that. But once you have the average, you can manipulate it even more, and you can find how far from the average is a certain number. So if I went to each of you and I said, let's take our final exam today, and one of you gets a perfect 100 out of 100 score, and one of you gets a 60 out of 100, but the average is 80, we can see how far. Oh, and then somebody else maybe gets like 79. It's sometimes hard to tell. This is a really basic example, but sometimes it's hard to tell how big of a difference is that? Like how far away from normal are we? And that's why we use things like normal curves. And variance is an important ingredient into getting to what that normal curve is and understanding how far away from normal we are. But variance is just a way to say how far is 90 or 100 or 70 or 79 or 60 or whatever, how far is that from average? Really, it doesn't matter all that much for the purposes of our of understanding what we need to. That's really a mathematical step. However, you will see standard deviation. And standard deviation is an important number that we'll have to get to, but I'm actually going to skip over it right now just in terms of like really digging into it, because what I described about variance, it really applies to standard deviation in the same way, but we'll see a picture of it in a second when we look at our normal curve, and hopefully it'll make a little bit more sense. And we're starting to get into the territory now where you will see standard deviation on different assessment forms in terms of like output reports and stuff. So you probably want to have that available to you. The one thing I will say is that most of the more complicated assessments will report things like standard deviation. We're going to take another step to talk about standard scores, and that's really the most useful and valuable thing to most of us, 95 to 99% of the time. So if you're still confused about standard scores, which you will be, most of us are going to be confused about them, and especially in terms of how we use them clinically. But we'll go over a bunch of examples in class. And what we're going to do over the next couple of weeks is really talk about some really practical stuff, look at some assessment output reports, and be able to make some interpretations about that. So we'll get to that part in a little bit here. I'm gonna read this though, just so we can talk about just a little bit more, so we can kind of lay a little more foundation for you. Standard deviations allow us to understand how individual scores relate to all scores. So this is why the reason this is relevant to us is because we want to be able to look at one person who we give a test to and understand how they fit next to all the other people who have taken this test, or all the other sort of normal understandings of whatever the test is for. So it's for comparison purposes, and that's why we want to know about this one. And I'll show you how to do that in a little bit with some pictures here. And this the stuff in the parentheses, you can read that, but I'll just explain it to you later as we get there. And this last part, I think, is just more of what I've already said, so we don't need to worry about that. We're going to go through all this stuff in class, and I'll explain this. But remember, just to put it in context, if you're listening to this and you're, 35 minutes into this, and you're like, what are we doing here? I'm confused. If you walk away with this and say, some of these terms sound familiar, Aaron is helping me build up to something important. So we aren't there quite yet, but we're getting very close. Okay, so if you're confused at this point, that's okay. This stuff will kind of come together full circle when we walk through it in class. So we're in a good spot here, even if you're confused. Okay, now I'm going to add. See, this is our second to last slide. I'm going to add a few other things, and this is going to be the end of what we're going to do today. But I'll give you a foreshadow of what's coming next week when these things will all start to come together. So by the end of today, it's not even going to still make a whole ton of sense together, but I'll try and give you enough foreshadow so that we can really pull this all together, probably next week, but some in class and that kind of thing. Everything that we've talked about so far is related to a single variable, okay? How do I want to explain this more? Think of it this way. If you give, if you're giving the PHQ, which we'll practice in class this week, if you give the PHQ, which is a depression scale, to a person in a waiting room or in your office or something like that, and you get back one score, what we want to be able to do is say, how do I take this one score, this one person with one variable? The PHQ is about depression. It's not comparing depression to other people or other symptoms or anything like that. It's one variable, and we want to understand what that means. When we talk about things like adding variables, we're really getting into the territory of things like correlations, okay? And that's more relevant to the research that we're going to talk about later. But we're talking about essentially one variable. And so when we go in class and we're talking about how do we understand this one test score, that's really what we're trying to understand here. Researchers and scientists, they manipulate different variables to understand the relationships between them, but we're really talking about just one client. How do we understand our one client and our one score? So that's why we're really focusing more on single variable science here. Do you have to remember that? Do you have to know that? Not really, but you'll see things like correlations and Pearson's R's, which I'll explain in a second. You'll see these things and you're like, how does this fit? Why do I need to know this? Well, correlations and Pearson's R are, both of those things are related to correlations, but most of the time we're just going to be caring about our one client. So I want to put those into a little bit of context. Now, for the rest of this, there's really just some kind of memorization involved in this at this point, and you'll probably get more of this in the research class. So I'm going to just sort of show you what you probably need to know for a test, what you probably need to just memorize. And we'll give some examples and talk about it a little bit in class, but it's probably not as relevant to you in your clinical work, okay? So this is going to be hard stuff to really digest and figure out like how you're going to need these things. I'm going to show you an example, actually. When I talk about correlations and them having direction and strength, I'm going to give you an example here. I'm going to say 1, 2, 3 here, just read these, and then I'll show you what those mean. So correlations have direction and strength. The direction refers to whether they're positive or negative. The strength refers to whether they're closer to 0 from 1 or from -1. Okay, I'll explain that in a sec. And so what you need to know about that is correlations, the number, the output of it. If you're ever looking at research and you see a correlation, it's always going to be a number between 1 and -1. And I'll show you what that means here on a picture here. So what you'll need, the part that you want to memorize is that if you see correlations, you're going to train your brain to understand between 1 and -1. If it's 1, it means it's a positive correlation. Anywhere between 1 and 0. So if it doesn't have a negative sign, it's a positive correlation. And if it's from 0 to -1, if there's a minus sign, then it's always going to be a negative correlation. That refers to the direction. The strength is how far it is from 0. So let's look at an example. We'll pull up this paint thing, see if I can use my mouse well enough. I usually do this on a whiteboard, so if we have to do this in class, we'll see if I can do it legibly. But let's take a graph. Let's say I want to graph out one client, and I want to understand two variables. I want to understand their well-being, and I'm just going to use a W here. Let's say a person's like wellness in life. Actually, we'll see if we can spell here in a legible way. And I'm going to compare that to this person happens to have depression. And let's mark session 1, session 2, session 3, session 4, session 5, session 6. And let's say I have like a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have a scale of wellness between 1 and 10, okay? So the first session, the person comes in and they score very low on the wellness. So they're like at a 1. We'll see if I can add some numbers here so that makes a little more sense. 1, 2, 3, and so on. At session 1, they score very low. They're not doing very well. Their symptoms are high and they're just not feeling good about life. But they come in and they say, okay, we'll do one session of counseling. And then they go through a week. And by session 2, they come back and they're like, oh my gosh, I feel better already. I'm at about a 3. My symptoms are starting to subside. I'm feeling a little better. And they go to session 3. And because you're such an excellent counselor and your counseling services are so effective, by session 3, they're already feeling really well and they're like 5 out of 10. Okay. And then they by session 4, 5, 6, whatever, by session 5, we'll just say they're like, way up to 10. What we see here is both a direction and a strength. So as they go, as depression, sorry, hold on a sec. I did this wrong. This always happens that I mess something up here. This is not depression. They do have depression, but what we need to see here is we need to see their session. Oh, where's my eraser? I'm on eraser. Get off there. Pencil. There we go. This represents the sessions. Some of you are probably like, this is not good science, Aaron. But you would be right. It's not. I'm describing this poorly. So these are sessions, not depression. But let's say this client does have depression, and these represent the sessions. By session 1, we can see that as they increase their sessions, their wellness increases. And by session 2, that goes up and wellness goes up. By session 3, session goes up, wellness goes up. And so both of these are happening in the same direction. They both go up at the same time, okay? So what we can see here is there's a positive relationship or a positive correlation between counseling and wellness, okay? And so if I measure those two, it's going to look like a positive relationship. So we can see the direction. And even if you look at this chart here, you can see kind of here, I'll see if I can do this in a blue line. This is probably going to get messy here. We see a positive relationship. So whenever we see a line like this in research, if the line goes that direction, then that means that we can see a positive relationship between these two variables. Okay, now let's see if I can erase this well enough. Probably won't do a super clean job, but that's okay. We'll do it well enough for our purposes today. Okay. Let me get rid of this too. Okay. Now let's say we have that same person, and instead of measuring wellness, we're going to measure something like depression. Okay. I need a better brush. How do I make it bigger? I have no idea. Oh, I don't want blue. I want black. There we go. Okay, now we're going to measure depression. At that first session, their depression is going to be a lot different than their wellness. Their wellness is going to be low, like we just said, but their depression is going to be high. So their depression is at 10. They're like in crisis mode, okay? By session 2, it's a little bit lower. By session 3, a little bit lower yet. And if these services are effective, they're going to continue to reduce in symptoms. And by session 6, their depression is down at a 1 and they've been healed. You are so good at your work that you've cured them which doesn't happen like that, but we'll just say for sake of example. And if we see a line like this, that means this is a negative correlation. In other words, session one, at session one, they're at a 10, but by session two, their depression goes down. Session three goes up, depression goes down. So the more treatment we give, the less symptoms they have. So it's an inverse relationship, an inverse direction. So this stuff, part of the reason it takes a while to grab onto this is like, why do I care? How do I understand this? When you're looking at research in counseling, and I will show you an example coming up this week, or if we don't get to it in class, at least you'll have an example paper about the efficacy of EMDR. I might find some other examples too, just because this article is getting a little bit old now. But when you're looking at is EMDR effective, and you'll see graphs and things that say like, people were given so many treatments of EMDR, and then we're measuring things like their well-being or quality of life. EMDR goes up, quality of life goes up. But we're also going to measure things like symptoms. As EMDR treatments go up, symptoms of anxiety or depression or bipolar or personality disorders or whatever they're measuring, trauma focused kind of things, those might be going down. And so you'll see some things going up and some things going down. And the reason I'm showing you this is because often the way they report it is just by giving a 1 or a -1, or more than likely it's not a 1 or -1 because those are strong correlations, but it might be something like 0.5 or 0.62 or -0.35 or something like that. And so we want to know what these numbers mean in order to understand the relationship between the treatment. As the treatments increase, whatever they're measuring might decrease or increase. The reason that's important is because oftentimes what we're trying to do, and I'm going to go back to PowerPoint actually so I can make use. Where's my button? There we go. I want to make use of my captions here. The reason it's important to understand whether these correlations are positive or negative is because ultimately as clinicians, what we want to know is it a good thing? When we ask the question, does EMDR work, or does this treatment work, or whatever it is we're trying to understand, we want to, in our simple brains, we want to say, is this a good thing or is it a bad thing? Is it effective or is it not effective? And when it comes to translating this into making good clinical judgments and understanding client conditions and ultimately providing good interventions that are useful to people, we want to be able to say, should I use it or should I not? And I'm really taking a very complicated thing and simplifying it into a yes or no decision. But that's kind of what we want to be able to do throughout this process. That's why we take flour and turn it into bread. Baking bread is complicated. Providing counseling is complicated. Science is complicated. But we want to really translate that into a very simple, manageable, and packageable thing that clients can use and we as clinicians can be confident in. So when we're looking at things like correlations, 1 or -1, is it positive, is it negative? We're practicing something that's hard and then turning it into something that's really basic and easy. And the more we simplify it, the less we get away from really understanding the complexity of the real world, but the more we get close to doing something that we can actually use. Okay, so there's a balance there. Scientists, and some of you who really understand this math, are going to say, we're just simplifying it too much. It's turning into a headline at this point. And it's turning into a fad thing that because it's simple, people can get it, but it really doesn't capture all the essence of what the truth is. And that's true. If you understand this math, you're going to have, or the math and the research parts of these and the nuances of it, you're going to have a more in-depth understanding than most people. But the ability to turn it into something that's useful is a special skill in and of itself. So if you are good at this, recognize that, understand that. But for clinical purposes, for using this in schools and helping parents and helping people live better lives, what we're trying to do is simplify it enough without losing the essence of what this really means, okay? And that's a tricky thing. So I'm deviating a little bit here, but I'm trying to put this in context for why we need to know this and how it's valuable for you. So the last thing I'll show you on this slide is Pearson's R. Pearson's R, if you ever see this lowercase r that's italicized, this is kind of complicated, but whenever you see this, basically what you're looking at is a correlation. So sometimes in you'll look at an abstract of a paper and it says the R value, and you'll see this little italicized R. Oops, goes that way. It's hard to do this on camera. When you see that, you can think correlation. That's what it means. So it'll always be R equals and then some value between 1 and -1. And that's this stuff up here in number 2. That's what it means. That's what we're talking about. There are, this should say variance or variations. That's a typo. There are other variations of Pearson. Sometimes you'll see the words phi or a Spearman's. Don't worry about those. If you see them, you can, if you remember, you probably won't, but if you remember that we're talking about correlations, then you can read the research and it's going to make more sense. But if you don't, oftentimes you'll see these terms and it'll still be between 1 and -1. And that's what that means. It's still a correlation. It's just a different kind. Remember when we talked about ordinal, nominal, ordinal, interval, and rank ordered? Spearman and phi are different ways of handling different kinds of raw data so that it makes sense. Earlier when I said they're different numbers and they represent different kinds of numbers, we have to have different mathematical calculations. That's what we're talking about here. So the scientists can measure the correct kind of number with the correct kind of tool and then make something useful to us. To use our bread analogy, it'd be like saying rice flour doesn't have as much gluten as bread flour, so you have to add a little bit more of a different ingredient to make sure it has enough binding agent. It's so that you can adjust the recipe to make it fit the final product. That's what we're talking about here. If you don't remember that, that's okay. Not that big of a deal. Okay, I'm going to fly through this part because we're going to talk about these things later, or they don't really matter all that much. A scatter plot, that's another term that I pulled out of the book that I thought I would make comment on. It's like a frequency polygon or histogram, but scatter plots are just another way of showing data. And it's a visual relationship between variables. So you'll see things like scatter plots. You guys have heard that term before in other classes, probably. And again, it's just another way of seeing the same thing, okay? Just a different visual representation. A regression is a more complicated thing, and we're not going to talk about that a whole lot. You'll probably talk about that one in your research class because it's relevant to the research. But if we think of correlation and we talk about trend lines and how do we understand these numbers together and what happens to all these variables, we're looking at a graph and we see a scatter plot and we're talking about a regression. What a regression really is it relates to those inferential statistics. It's not each individual descriptive data point. It's what can we infer about this based on a trend line. So if we go back to my paint program here, let's say I'm doing a regression analysis and I see this big line here, and I really only have, let me use a different color here. Let's say I have all these data points here, 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 here. This is really messy. Sorry about this. Here. And this is what actually was collected by me, and it's like the truth about what happened in the world. But let's say I know that there are other people out there probably experiencing even lower depression scores or maybe even higher depression scores. What I want to do is I want to be able to infer about the likelihood of something that I don't have information about. So when we do like a slope line, do you remember slope from math class? And you take 2 points on a line, make a slope, and then you can say, well, if I know the X score, I can find the Y score. That's essentially what a regression is we're trying to figure out how I can understand what something more from what I have already. So that's just a really basic example. I'm not even going to read this one because hopefully that makes a little bit of sense. But again, you'll learn a little bit more about that in your research class, or if you don't, that's okay. Just know that when you're looking at a regression in the research, that's what it is, and you can look it up. That's what Google and ChatGPT are for these days, is just understanding more things. On the last day of this little mini series, when we're going to talk about reliability and validity in 2 weeks, we're going to talk about standard error. Standard error is important because just because you run this through the mill of math processes doesn't make it perfect. It doesn't mean that it's exactly right, because there's always going to be error in the process. When we talk about, we have categories. Remember at the very beginning of this lecture, I said, a kid learns that a ball is round, and then there's red and blue, and then there's a football and a soccer ball and that kind of stuff. eventually they're going to run into something that bounces, it has color, it has shape, but it's not a ball. It's something else. And they're going to say, I think that's a ball. And they're making an error because we make errors in the process. Or when they're talking about people, like categories of people, we have biases against certain people and we make mistakes about what they can and can't do or who they are and what their value is. That's just error in the process, okay? So this is the mathematical equivalent of saying we get it wrong sometimes. And we can actually figure out how to account for how wrong we are. So we're going to talk about what that means later on. But just know that if you're like, part of the reason I don't like the math is because it feels like the math is so clear that it can't be wrong, and yet it can be sometimes, and we can try and account for what that means and how that works. I'm not going to go through all the math. We'll talk about it a little bit, but what we need to understand is how do we read the final output scores and understand the error well enough to say, at least we're talking about within this window. If you're a stats person or you've taken this before, you maybe heard of the term confidence intervals. Confidence intervals show up on our assessment output reports frequently, and I'll show you those in class. They show up on those reports and they refer to error and how much this is probably wrong. The reason that can be useful, I'll say this again later, but the reason it can be useful is when people say, I don't think that's the score that I should have gotten. I just took the ACT and I got what's an ACT score? Like I got a 17 or whatever. I got a 17 on the ACT score. I think I could do better because this day I had a headache or I was late and I was anxious because of drivers on the road or whatever. I don't think this represents what I really would have done because I'm way smarter than that. And what we can do is say, well, based on everybody else who's taken this, who's also dealt with traffic and headaches, they've scored on second administration this high or this low. And so we can say you're probably going to fall within this window. So even if your intelligence didn't show this on this day, it's probably not going to be a 30. You know what I mean? So you can talk to people about how much might we have gotten this wrong. So you're probably within this window. This is really useful when you say like, you know, the likelihood of your symptoms getting worse based on your presentation right now. The research shows is you have a 50% likelihood of this getting worse or this treatment working or something, but it's probably somewhere in the range of 40 to 60% chance, something like that. Those kind of numbers can be helpful for people to consume. And so we'll talk about those as we get there of like, how do we understand that part? Factor analysis. Now this part, I don't want to spend a ton of time on because really, maybe we'll come back to it later when we talk about personality assessments. But factor analysis is a way that researchers and scientists take a whole bunch of information, do a bunch of really fancy math, not just not just measures of central tendency, variance, standard deviation, and turn it into a percentile or standard score. That's our process for clinical decision making. But this is more how science is developed and tests are developed. So one of the things we'll talk about eventually, probably even after our stats chapter, is it's kind of important to be able to read a test manual and know how to understand whether it's a good test or not. When we're talking about choosing tests, you might say, well, everybody's using the PHQ and the GAD-7, so it's probably pretty safe to use in terms of is it useful or is it like scientifically credible? And most of us will just look out at the world and say, if it's out there and it seems popular, it's probably good. If you've ever used the Google star rating system to buy a product, we just look towards popularity. But that doesn't mean it's a good product. It doesn't mean it's effective and it's not going to break, right? So we want to have different metrics for understanding it other than just popularity. Factor analysis is how the test is developed. And the reason we're doing reliability and validity scores, I'm fumbling my words a little bit, and we're talking about how tests are developed is because we want to actually not just look at popularity of tests, but train you how to actually understand, is this test good? Do I understand the validity? Do I understand reliability? And do I understand how it was built so that I can say when I have this one specific client who, when we talk about things like diversity, if this client is from a different cultural background or different gender or whatever, if this test is not fit for them, we want to be able to tell that so we know if we're getting good data or not. So that's why we're doing this. Really quickly, a factor analysis is basically taking a whole bunch of information, putting it in through a factor analysis calculation, and outputting what does all this information have in common. So the classic example is the 16PF. 16PF is the 16 personality factors. So when we get to the personality assessment section, we'll talk about this one again, just briefly. But essentially what the people who developed this did is they took all of the words out of a dictionary that refer to personality. Happy person, sad person, introvert, extrovert, person is charismatic, or are they pensive, or just all these different words. And they're like something like, I think if I remember correctly, like, oh, it says right here, 14,000 different personality words. And they said, well, there's a mathematical process that we can look at by giving people all these words and telling them to match them up. So happy and cheerful are kind of the same thing, but they're a lot different than sad and depressive. So what they did is they want to put these categories of words into different chunks, or what they call factors. And if they do all of that work and put all these words into different categories, what they've come out with is there's 16 different types or similarities or factors that make up all of our words for personality. So if we really want to filter down or distill all of that information from 14,000, what we do is we have a process to come out with what's the essence or the core of the human personality. And they said, according to them, there's multiple other versions of how we understand personality, and we'll get there. But what they said is there's 16 different factors that come out of that. Just one example of how tests are developed, but it's helpful to know that, to know whether it's a test that you want to use or not. So we are at the end. This is an hour and 1 minute. We're at the end of this week's chapter. What I want to show you is one quick thing, and then we will come back to this next week. Let me zoom in here. These are pages out of your book. This looks horrendous. It's just ugly and doesn't really look all that great. But I've mentioned things like a normal curve, and that's what you see right above my head here. I've talked to you about the word standard scores, and that's what you see above my head here. What we're looking at here is this normal curve, which you've seen before. If you can see these like faint white lines here, those are actually the different standard deviations, and I will show you how to use those next time. And then you'll see these things like T-scores and percentile ranks. This is the information that we actually want to use. And in your book, there's actually this. I don't think this is actually from your book. I think this is from a different one now that I look at this. Oh yeah, it's from that Essentials of Assessment report writing. So I'll show you another version of this from your textbook when we get to class. But it's the same stuff. If you Google this, you'll see the same thing. And if you can read one chart, you can read all the charts. So these are the important things that if you go from like frequencies to measures of central tendency, you find the mean, then you find the variance, you find the standard deviation, and then you can find these things. And these things are what show up on assessment reports. Here's an example. The Wechsler Intelligence Scale for Children, or the WISC, that's a name that you're going to want to remember because it shows up on testing, on like your NCE test, or if you take the NMHCE test, you'll see those names like this. And we'll go through more of that too. We'll talk about that later. You'll see an output scale like this. If you understand what a percentile rank is, then you'll understand how to talk about this to other people. We haven't explained that yet, and I'm not going to today just because for the sake of time. But we will probably talk about this in class. I'll explain this to you. So if you watch this video and you say, I don't get it, it's confusing, or I understand parts, but it doesn't really all come together. To go back to our puzzle analogy, what we've done is we've flipped over the pieces. And so we see all the colors, but we don't fully have the picture in our mind yet. And that's to come. So we have to be patient with this process a little bit because it's not something we can do in neatly packaged 1 hour increments. So hold on to this, come to class. I'll pull this up again. We'll pull up our textbook. So you might want to bring it with you this week to make sure that we can open it up in front of us and look at it. Otherwise, you can just follow along with me on the projector. But if you need to see it in front of you or make notes or something like that, it might be helpful to have it. And we'll go through this. By the end of class period, what we're going to do is we're going to talk about the PHQ, the GAD-7, Beck's Depression Inventory. There's There's another scale that I learned about last week or last year that I want to bring in, and we'll go through some of those, and then we'll also talk about this stuff. And so this will all kind of start to pull together and make a little bit more sense to you by the end of this week. And then we're going to build on it for the next 3 weeks to understand the really technical, mathy kind of stuff. So hopefully this gave you enough foundation to make some progress. And it's not, by the end of this, my goal is to reduce the anxiety for many of you and to not oversimplify it for those of you that are really excited about this stuff. But again, all this is about making good clinical decisions, choosing effective interventions, and understanding people's conditions as they accurately are in the world and how they accurately experience them. So I think that's all I have for you, and I will see you in class later. Bye-bye.